Hi everyone, this is Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. So in this particular video, I'm going to explain about the referential integrity, because integrity plays a major role while creating a table. So because whatever the conflict occur while entering the data, while updating, deleting, that particular thing only we can call it as a integrity constraint. So each and everything, definitely we are having certain constraint for inserting the thing. Because without the constraint means that is not a normalized table, that is not a perfect table. So for that, while making it into a normalization only, we are providing certain integrities to the relational or a schema. So before that, we can go through the definition. After that, we will see that one. So here, well-known that thing, an attribute, a set of attribute can contain under the relation, the entire structure only we can call it as a relational schema. At particular time, what type of a data are present, or what are the tuples present inside the table only can call it as an instance. That only I defined over here. Example, instructor is my relation. A schema can contain four attributes: ID, name, department name, and salary. So this relational instant, I can define it by R of small r of capital R, or capital R defined the relational schema, that is capital or small r, can be defined as an instant at that particular time. The current value in the instance, this specified in the table only, we can call it as an instance. And also tuples, we already seen the element T of the relation or can be call it as a tuples. The next thing is an attribute. An attribute can contain the different types of a domain. So the set of allowed value for each attribute only we can call it as a domain of the attribute. That attribute require the atomic, that is an individual value. In the special cases, it can be a null value. Automatically, it is an unknown value. Automatically, the system itself, it will be take it as a null value. If null value causes complication in defining a many operation. So by using, while doing any operation, if you have a null value, means we couldn't able to do anything. If you are setting it is in a primary key, if you doesn't have a roll number, means I can't able to identify that particular student detail. Is it right? That is not a meaning. We can't able to do a certain things. For that only we can specify the thing. If you want the value must be present, means definitely we have to give that particular constraint in the table. While giving the schema itself, this particular table should not contain a not null value. So definitely the user must enter certain value while over that. So these are the thing we going to give it for the attributes. So while defining an attribute itself, we're going to specify the constraint or a integrity. The next thing is, normally a relation is an unordered. If we want to order only, we can able to do it. Always our data or a tuples can be stored in the arbitrary order. That is a irrelevant order. So this is not a shorted order. The next thing is, this is a schema, logical structure of a database. The snaps of our data in the database at the given instant of time, we can call it as a database instance. So, and also key. So key, we already seen in my previous video, we have discussed about the 7 different types of a key. In that thing, the major two thing is a super key and the candidate key. So super key is if sufficient to identify the unique tuple of each possible relation, only we can call it as a super key. So in a super key, if which one is a minimal subset, that can be called it as a candidate key. For example, I'm having an ID. The another set can have the ID and name. These both are the super key for the relation instructor. So which one is a candidate key out of these two? Means ID is a candidate key. How I can say this one is, this is a minimal subset. Here only one subset of key. Here it will have a 2 subset of key. So only I can say the ID is a candidate key. One of the candidate key, only we're going to choose it as a primary key. So in the next thing is a foreign key. So foreign key, definitely while mentioning in the foreign key, a primary key can be acted as a foreign key in the another table. For that we have to give the reference. From which relation we are referring this particular ID is a foreign key, that we have to mention it over here. For example, department name in the instructor is a foreign key. and from instructor referencing that particular element that we have to mention while creating schema itself. When we can face the integrity constraint means, how we can know this thing means, you have created all the key for that particular table. After that, if you are inserting certain values to the table, definitely you can arise, you can able to face all type of integrity. So here I have shown the schema for the university database. This is a simple schema. This is the overall structure for the university database. Next thing is, while being the constraint, it will have a 3 different type of a constraint. One is a domain constraint, key constraint, and referential integrity. Domain constraint is nothing but here you're having a table. A table contain name, ID, mark, and age. So why I'm saying this is a domain constraint means, those who are having 18 plus age only, they can able to applicable to enter this particular value. I'm setting the constraint for this particular attribute. For checking, age must be a greater than 18. If suppose I have entered 17, means that particular data is not entered in this particular table. Only if the age must be greater than 80, some notification it will be sent to us. This type of a constraint, we can call it as a domain constraint. Next thing is the key constraint. Key constraint is nothing but here you are having an employee ID, employee name, and salary. So for example, employee ID, I can set it as a primary key means we have to give some key over here. If it doesn't give the key means it will not accept the value, because if you are setting it as a primary key, it will not accept the null value. So this type of an integrity, we can call it as a key integrity. The next one is the referential integrity. Referential integrity is nothing but a reference that is the related to foreign key. For example, in this particular table, department ID is a foreign key. So here, if I have the relationship means here also one, here also one. This is a one-to-one relationship. So for that only we are using a referential integrity. While doing this thing, definitely an anomaly is occur. So anomaly is nothing but there is a 3 types of an anomaly. One is a insert, update, and delete. This we're going to see in detail in the normalization section. First, I have to say it is an insert anomaly, update anomaly, delete anomaly. So insert, if I want to insert any value, for example, IT department means I can't directly enter the IT department, because an IT department can contain so many students. I have to give a student name, everything. I can't directly enter the IT department. So similarly, I have to do some update means if I want to do any update means I have to go for a certain thing. If I want to set a phone number for this thing, and also another thing also I having the same phone number, I can't able to modify the thing. So in delete anomaly is, if I want to delete the particular student, here particular department, a college can contain so many department, is it right? If I want to remove the EC department, I can't able to remove, because EC department we are having so many sections, so many students are there. So directly I can't able to remove the EC department. So these type of a thing we have to overcome while inserting, updating, and deleting the values. So I'm going to explain detailedly in my normalization section. Thank you for watching my video.